Good morning, everyone. Myself, Monica Nancy Priya, Assistant Professor in Department of Electrical and Electronics Engineering. In this semester, I'm handling Basic Electrical and Electronics Engineering in the subject code W25C01 in the regulation 2025. Today, we will study one of the most important semiconductor devices used in electronics, that is the bipolar junction transistor, BJT. So, in this, the topics covered are overview and introduction, structural design, working principle, types of connections, testing methods, and applications. So, at the end of this session, the students was able to define a transistor, explain the construction of a BJT, what is the difference between NPN and PNP, understand the current flow in a transistor, and also the basic operation of a transistor. Next one is the introduction. A transistor is a three-terminal semiconductor device used for amplification of signals, switching operations, and the three terminals are collector, base, and emitter. Um, in this three terminals collector, base, and emitter. So the bipolar junction transistor was invented in 1948 at Bell Telephone Laboratories. This invention revolutionized uh, electronics base, how it was a revolution in the electronics base because it replaced the bulky vacuum tubes. So later the MOSFETs became the dominant integrated circuits, but BJTs are still widely used in amplifiers, analog circuits, switching circuits. These are all we are using the BJT. So why are transistors called the building blocks of electronics? So because they perform the amplification and switching functions in almost every electronic device. So next one is the importance. What is the importance? The importance of the BJT semiconductor device, or in this BJT, the modern electronic system rely heavily on semiconductor devices. So the example is diodes, transistors, MOSFETs, ICs, that is the integrated circuits. Among these, BJTs are extensively used because they can act as the amplifiers. So the small input signals become larger output signals. So for example, microphone amplifiers, audio amplifiers. The next one is the switches. It's used in the digital electronics. So the example is the computer circuits, logic gates. So these are the used in the digital electronics as switches. And the types of BJT. What is the types of BJT? There are the two types of BJT. That is the NPN transistor. That is the structure is NPN. So the majority of the carrier. This is the N PN. So the majority of the carriers are electrons and the most commonly used transistor. And the PNP is nothing but in this place we are having PNP. So the structure is PNP. So the majority carriers are poles. So the current direction is opposite to NPN. So from easy memory topic, the trick that we are using is NPN is not pointing in. So the emitter arrow points outside the emitter. Okay, so NPN means not pointing it, so it's out pointing. Okay, out pointing to emitter. So you can easily remember. So that's only I'm telling. Then one is a PNP is pointing in proudly. This is the PNP. The pointing is in proudly. So PNP is pointing in towards the collector, and the NPN is out towards the emitter. So these are the two important points. So the emitter arrow points inward. So the next one is the device architecture. In this, the transistor consists of the three semiconductor regions. One is the emitter, base, and collector. The emitter, that is a very heavily doped and supplies the charge carriers. And the base is very thin and it was a lightly doped and controls the transistor action. Next one is the collector is the moderately doped. This is the heavily doped, this is lightly doped, and this is the moderately doped. Then it collects carriers from the emitter. Next one is the this NPN, the emitter, that is the N type. This is the N type. So this N type, and the base is the P type, and the collector is the N type. For PNP, P is the emitter region, N is the base region, and P is the collector region. So these are the structure of PNP and NPN. So this explains, observe the diagrams carefully. So NPN is emitter, base and collector, and PNP is also emitter, base and collector, where P refers to emitter, N refers to base and P refers to collector. The base is always located between the emitter and collector. So the base region is extremely thin to allow most charge carriers to pass through and reach the collector. Next one is the overview of transistor design. In this, the transistor consists of two PN junctions, that is the emitter-based junction and the collector-based junction. So each junction can be a forward bias and the reverse bias. Each junction have a two biasing system, that is the forward bias and the reverse bias. Theoretically, there are the four biasing possibilities. That is, only one condition is normally used for amplification, that is the active region. The emitter-based junction is the forward bias and the collector-based junction is the reverse bias. This is the most important operating condition. So this is the operating view of the transistor design. And why it is called the bipolar? Why we are saying this is a bipolar? The term bipolar. Why the term we are using the bipolar is there is a two types of charge carriers participate in the conduction. One is the electrons and holes. In MOSFET, we mainly depend one type of carrier. That is, but BJT is the bipolar. So that the name BJT having the B, that is the bipolar use both. So hence the name is the bipolar junction transistor. Next one is the terminal layout and symbol. In this, the transistor symbol contains a collector, base, and emitter. That is collector, base, and emitter for both PNP and NPN. So the important feature is the emitter contains an arrow. In this, the emitter contains an arrow. If the arrow is inwards to the base, that is the PNP, and the arrow outward to the emitter, that is the NPN. So the memory rule already we see, no. So the arrow will point towards the N region. The student often get confused here. So please memorize this arrow. The PNP is the point inward proudly, and the NPN is the point outward. Okay. So the next one is the transistor currents. What is the transistor current? There is the three current flows in the transistor. That is IC, IE, and IB. In this IB is the base current. That is a small current. The controller transistors the action. Next one is the collector current. This is the large current. This is only the output current. So the emitter current is the total leaving current or entering emitter. So this is the total current. So IE is equals to IB plus IC. So according to the Kirchhoff's law, the total current entering to the node. So this is the total current. This is the total current entering to the node equals to the current leaving the node. So the emitter current is inward and the collector and base current is going outward. So emitter current is equals to collector current plus emitter current. So for example, if collector current is 9 milliamps, the base current is 1 milliamps. So the emitter current is 9 plus 1, 10 milliamps. Okay. So you have to understand that transistor currents. Next one is the direction of the current flow. How the current flow gets the direction? In this current flows emitter to base. Here is also in NPN transistor, the current flows from base to emitter. So the important note is the conventional current direction is considered here. Actually, the electron movement is opposite to the conventional current. So commonly the current flow with the electron flow. Next, how a transistor works, the working principle of a transistor. To understand the operation, consider a PNP transistor. So the same principle applied to the NPN transistor also with the opposite carrier movement. So the condition is one is the forward bias, the other junction is the reverse bias. So this allows the transistor action. So first one is the forward bias junction. When the emitter base junction, this is the emitter, this is the base, this is the emitter base junction, this is the forward bias. Majority carriers gain energy. So they move across the junction. In PNP transistor, hole move from the emitter to base. Here, this is the emitter, this is the base. So emitter to base. This movement initiates the current flow. So there is the current flow between the emitter and base. In reverse bias, the collector base junction. This is collector, this is base. This is the collector base junction is the reverse bias. So we are having -2 plus this reverse bias will happen. So normally the reverse bias blocks the current. So however in the transistor, the carriers injected from the emitter or swept into the collector. This is the secret behind the transistor amplification. So the carrier movement is also very important. In a PNP junction, the holes are injected from the emitter and they enter the thin base region. So very few recombine in the base, most reach the collector. So the small base current, that is IB, is the microampere range, and the collector current, that is large current, it's a milliampere range. So why is the base thin? The base is intentionally made, so it is very thin and lightly doped. So how, why? To minimize the recombination. So as a result, 95 to 99 percentage of carriers reach the collector. So only a small percentage of the uh, current contributes to the base current. Next, the collector current components is also having the collector current consists of the majority charge current. It's mainly useful current. The collector current is output current, no? So it is the majority mainly useful current, and the minority carrier current is a very small leakage current. So the mathematically IC is equal to IC majority plus IC minority. So the leakage current is exists when the emitter is open. The current is called the ICU. So the characteristic is very small and it's what's unwanted current, and it always increases with the temperature. So what are all the uh, points we discussed today about the BJT? The transistor has three terminals, that is collector, base, and emitter, and it having the two types, NPN and PNP. So the three terminals, that is base, that is a thin region and slightly doped, and the emitter it's a heavily doped, and the collector it's a moderately doped. So the current relation is emitter current IE is equal to IC plus IB. So it's always used as an amplifier switch. So the real-time application of the BJT is also audio amplifier, radio amplifier, microphone circuits, switching circuits, control systems, consumer electronics. These are all the real-time application for the BJT. Students, I hope that this topic will help you more. These are the basic things about the BJT. Uh, through this video, you have to you study the most basic components of these semiconductor devices, BJTs, PN junction diodes. We will see the next topic in the next video. These are the references. Thank you.